Okay, so we're only going to do some of these. This is Unit 9. These are just some review, some concepts we're going to need for this unit. So I'm going to do number 2. 13 squared is 169. And 25 squared is 625. We need to get all the numbers on the same side, so we're going to subtract 169 from the right side, and we get 456. We square root both sides, and that means x is the square root of 456. Now, if you remember from algebra, we want to see if there are any perfect square numbers that go into 456. So you just take your calculator and you try perfect square numbers. This actually breaks down to 4 times 114. So that means we can take the square root of 4, and the answer is 2 times the square root of 114. That's the most exact answer for that problem. 114 does not break down in any perfect squares. It actually breaks down to 2 and 57, which is not, this is both prime numbers, so we know we're done. Actually, let's step back and do number 1, since it's going to be an easier number, because they do work out nicely sometimes. This is going to be 16 plus 9 equals x squared. 25 equals x squared. And then when you square root both sides, you get a nice number like 5. Okay? We're going to skip 3 and go on to, let's say, number 4. Yeah, that's a good one. Actually, let's do number 6. Radicals all over the place. So have some fun with it. So when you square a radical, you square this and this. So 5 squared is 25, and the square root of 10 times square root of 10 is just 10. Because the square root of 10 is really 100, and square root of 10 squared is the square root of 100, which just works out to be 10. And then when you square square root of 2, you just end up with 2. Okay? So that's 250 minus 2 equals x squared. So that's 248. Now, we wanted to square root both sides. That's going to be x equals 248. And now we're going to see if any magic numbers go into 248. And once again, sorry, this should be square root of 248. It does break down to 4 and 62. Square root of 4 is 2. So that's going to be x equals 2 radical 62. And we can test this one, but 62 breaks down to 2 and 31, both prime numbers. So that means we can't go any further, and we're done. Okay, find the perimeter of the shape with these vertices. Okay, we're going to skip down to what says number 4, but it's actually the third one, because that has 4 points. That's going to give us the most practice, and then you can have the other 2 just for practice on your own if you need it. So let's real quickly think about what this would look like. You can just roughly sketch it. 3, 6 would be up here. That's T. Negative 4, 6 would be up here. That's U. Negative 1, 2. That's going to be right here. That's V. And 6, 2 is going to be out here, and that's W. Okay, so if you think about it, you have what looks like a parallelogram. We don't know for sure because I just roughly sketched it. But if you think about it, since T and U are both have a y of 6, that means you can literally just count from negative 4 to 3. Okay? So you don't have to do the distance formula on a shape like this. You can literally just count. So from negative 4 to 0 is 4 spots, and then 3 is 3 spots. So that means on this shape, which I just drew backwards, on the shape, that's a horrible drawing, these are both 7. Okay? Because then we can do that here too. Between these two, negative 1 to 0 is 1 spot, 0 to 6 is 6 spots, so that's 7 on those. So basically, we just need to find the distance between T and W and U and V. We can't assume they're exactly the same. So we have to practice the distance formula twice. So remember, that's going to be x minus x squared plus y minus y squared. So let's do TW first. So I'm going to do 3 minus 6 and 6 minus 2. Very simple. So 3 minus 6 is negative 3 squared. 6 minus 2 is 4 squared. So this is going to be 9 plus 16, which is the square root of 25, and that's 5. So TW is 5. And then we're just going to do it one more time. Again, I like to set up my shell first, and then fill in my numbers. So now I'm going from U to V. So I'm going to do negative 4 minus negative 1, which is going to become plus, and 6 minus 2. Well, negative 4 plus 1 is going to look very familiar. That's going to be negative 3 squared, and that's going to be 4 squared. And as you can tell, that is the exact same thing as right here. So these are both 5. So 7 and 7 is 14, plus 10. The perimeter is 24 units. That's it. Okay, now on to the new stuff, which is really not that new. The Pythagorean Theorem. You've done this in algebra already. The right triangle, this side is always the hypotenuse. It's the longest side. Very important to remember that. A and B are interchangeable. It doesn't matter which one you call A and B. Okay? Okay. These are some common what are called triples. These are numbers that always form a right triangle. The most common are the top ones in bold, and the ones underneath are just multiples. So, times 2, times 3, times x. Okay? So that's all that's happening there. Not bad idea to have some of these memorized, especially the top 4. Just makes your life easier when you're dealing with Pythagoras. Okay, so here we can call this A and we can call this B, or vice versa. It doesn't matter. So I always suggest start by writing your basic formula first, and then fill in your numbers. 5 squared plus 12 squared equals c squared. Now, you notice, you already know what the answer is going to be if you know your triples, but if you have to prove it on a test, just go ahead and do it. 25 plus 144 equals c squared. 169 equals c squared, and we square root both sides. We get c is 13, which we knew it was going to be anyway. Okay? So, now this time, notice, we have A, we have C, but we're missing B, or A, however you want to call it. This is why I always say do this first. One of the most common mistakes people make is to just say 7 squared plus 14 squared equals x squared. We're not always solving for C. So, 7 squared plus b squared equals 14 squared. Okay? So now we're going to do the math on that. 7 squared is 49. And then 14 squared is 196. Now I'm going to subtract 49. We're not adding. Don't just do it in your head. If you need to show the work, show the work. We're subtracting 49, which gives us b squared equals 147. To finish, we square root both sides. B equals. Now, there are two types of answers here. You can approximate the answer and say the square root of 147 is 12.12. That is not, you're going to hear us ask for the exact answer. That's not an exact answer because it's actually 12.124355565. That's a rounded answer. So when you leave it in radical form, that's actually the exact answer. So whenever we ask for exact answer, exact means radical. Unless it's a perfect square like 25 becomes 5. But if it's not a perfect square, leave it in radical form when you're asked to do exact answers. Okay? Now, we're going to see if 147 has a perfect square inside. Now, when we check 147, it actually breaks down to 49, which is a perfect square, times 3. So the exact answer for this is b is equal to 7 radical 3. That's the exact answer. This is the approximate answer. Obviously, if you were building something, you'd have to go with a decimal because you can't measure things in radicals. Okay, skyscrapers are connected by a skywalk. Use the Pythagorean Theorem to approximate the length of each support beam. Okay, so we know this side right here is 57, sorry. This whole length here is 23.26, but we only need half of that. So 23.26 divided by 2 is 11.63. Now what are we looking for? We're looking for our C, our Pythagorean, our hypotenuse. So we have A, we have B, and we're looking for C. So we're going to put our numbers in that we have. 11.63 squared plus 47.57 squared equals C squared. So this is 135.2569. In this case, it's probably a good idea to leave the decimals and wait till the end. And then 47.57 squared is 2,262.9049. Okay, so now we're going to add those two together. You don't want to round here and then round later because you're getting further away from the answer. It's best on something like this, especially with measurement and engineering, to be as exact as possible. So C squared is equal to 2398.1618. We're going to square root both sides. And we're going to get a decimal answer here because we started with decimals. And we're going to get C is equal to 48.97 meters. That's our answer. Remember, anytime you need to, hit pause, go back. Okay, the converse of the Pythagorean theorem. Okay, this is just going backwards. So if the square of the length of the longest side is equal to the sum of the squares of the other side, we have a right triangle. So if we can go backwards and prove if that is a right angle by working backwards. So if we're assuming that the right angle is here, that's what we're trying to prove. That makes this A, B, and C. So we plug that in and see if we get that. So, don't know what happened there, my bar disappeared. So 7 squared is 49. 8 squared is 64, and we're going to see if that equals the square root of 113 squared, which is just 113, because these cancel each other. So 49 plus 64, 113 equals 113. Check. We have a right angle. Okay, right here. We're checking to see if this works. So we're going to say A, B, C. Okay, so 15 squared plus 36 squared should equal 4 root 95 squared. Okay, so 15 squared is 225. 36 squared is 1296. Now remember, when we square this and this. So 4 squared is 16, and the 2 undoes that, so that just leaves 95. So 16 times 95 is 1520. On this side, when we add 12 96 to 225, we get 1521. Ooh, very close, but not a right angle. Which means, being that it's that close, it's probably like 89 point something degrees or 90 point something, but it's not 90 degrees. Okay, inequalities. So in this case, when we look at the numbers and do a squared plus b squared and compare it to c squared, if c squared is greater, okay, we have an acute triangle. I'm sorry, if c squared is less than the sum of the other two sides. If c squared is greater, we have an obtuse triangle. So, we're going to see, we have a triangle, 4.3, 5.2, and 6.1. Sorry. 6.1, come on. 6.1 should always be, the longest side, obviously. So that is our suspected right angle. Okay, our hypotenuse. Okay? So that means we need to do 4.3 squared plus 5.2 squared and compare it to 6.1 squared. So 4.3 squared is 18.49, and we're not going to round. Plus 5.2 squared is 27.04, which adds up to 45.53, which we're going to compare to 6.1 squared, which is 37.21. Now, let's go say 37.21 is less than the addition. So remember, this was our c, this was our a squared plus b squared. So let's go back. If c squared is less, we have an acute triangle. Okay? So if it would have been greater, we would have had an obtuse triangle. And that's it.